Okay, let's talk about midpoint on a coordinate plane. Again, it's still based on the same definition, but this time when you're looking at the midpoint's going to be a set of coordinates. Okay? So the set of coordinates is just going to be an average of the x's and an average of the y's. Okay? So the midpoint on a coordinate plane is the average of the x coordinate, average of the y coordinate. Okay? So you can see the calculations. The sum divided by 2, the sum divided by 2. So it's the same calculation, only you have to do one for the x coordinate, one for the y coordinate. So if we were to go in and look at this first example, again, it's the straightforward example. Okay? You just apply it directly into what you have. So if we took midpoint, now you don't have to sketch it, although sometimes sketching helps you identify whether something is an accurate or potentially accurate answer. So if we took the point P, which is 9, negative 3, and we took 3, 1 for Q, and we looked at where would we anticipate this midpoint to be. Okay, so the midpoint is going to be somewhere, again, you can kind of see in between the 3 and the 9 for the x coordinate, in between the 1 and negative 3 for the y coordinate. So as we calculate this, the midpoint of PQ is going to have two coordinates, an x coordinate and a y coordinate. So if we take the average of the x's, 9 plus 3 over 2, and the average of the y's, negative 3 plus 1 over 2, we can simplify our answer. 9 plus 3 is 12 halves. Negative 3 plus 1 is negative 2 halves. And so we get our final set of coordinates to be 12 halves, which is 6. Negative 2 halves, which is negative 1. Now, is this location consistent with the coordinates 6, negative 1? Yeah. Again, you're not going to be precise with the sketch, but it at least gives you a general idea if you're in the right ballpark. Okay, so again, sketching is not required, although it's probably helpful to use it just to help verify the consistency of your answers. But the second example is a little more complicated type of example that you might see, and it demonstrates the concept of, in this midpoint formula or set of coordinates, each of these calculations is completely independent. The first one is the x coordinate, the second one is the y coordinate. So when you get some of the more complicated or complex problems, you might have to use the individual calculations for those. Okay, so if you want to find the coordinates of x, given y has coordinates of negative 2, 2, and the midpoint is given as z with the coordinates 2, 8. So what that means is, if you were to sketch this, okay, the pieces that are provided for you is 2, 8, so here's z, okay, and then negative 2, 2, here's y. And if z is your midpoint, then that means that x is going to be somewhere up here, right? So you can anticipate what your coordinates for x have to be, but you're told what the average of the y's is, you're told what the average of the x's is, and so you're going to need to do the calculation independently on each of those. Okay, so if you want to find what the coordinates for x are, what you're going to need to do is start with the expression for just that x coordinate. Okay, oops. Because you know that this is equivalent to 2. Okay, so if we took x1 plus x2, well, what is our known x value? So here's x2, negative 2. That has to equal this expression that's given for our midpoint, 2. Okay, so what we're going to do is we're splitting this midpoint formula into individual parts. We're just going to solve for the x coordinate. So we're using this 2, we're using this given x coordinate, and now we can solve that equation. So if we multiply both sides by 2 to get rid of our fraction, the 2's cancel, leaving x1 minus a 2 is equal to 4. Add 2 to both sides, we get x1 as a value of 6. Okay, so we found our x coordinate, and now we're going to do the same thing with the y's. So this expression has to equal 8. And so we're just going to take that individual equation. So y1 plus our y2 value. So once again, we come down to our known point is 2. So y1 plus 2 divided by 2 has to equal the given coordinate of our midpoint, 8. And then we solve that individual equation. So if we multiply both sides by 2, again, get rid of our fraction. y1 plus 2 is equal to 16. Subtract a 2 from both sides. We get y is equal to 14. Right, and so here would be our coordinates. So the answer to this problem is 6, 14. And we can confirm our answer. If we wanted to check to see, is this correct? We simply take a look. Is the midpoint 2 halfway between, or the midpoint of -2 and 6? So if you take -2 plus 6 is 4. 4 divided by 2, does that equal 2? Yeah, so that one checks. If we do the same thing with the y coordinates. Okay, so 2 plus 14, if you add those two together, you get 16. Is 16 halves equal to 8? Yeah, so that one checks as well. So once you check these, you should have some certainty that you have the right solution.